Welcome to Boundless Cosmic Tales. So, what are moonquakes? And could they be dangerous for future missions to the moon? What causes them? And what can we learn? Unlike quakes on Earth, moonquakes can last over 10 minutes, much longer than we experience here, and they aren't caused by shifting tectonic plates either. Let's dive into moonquakes and look at some interesting things happening to our moon and, in the future, how these lunar problems could affect life on the moon. We actually discovered moonquakes from the Apollo missions on the moon. Starting with the very first moon landing, Apollo 11, we placed seismometers to collect data about the lunar surface. These seismometers collected all kinds of data about the different types of moonquakes. For instance, they last much longer than on Earth but aren't as powerful. And they created a whole network of seismic stations on the moon. They operated until 1977, transmitting data back to Earth. Scientists have been going over that data for the last 47 years, and they have revealed 4 main causes of moonquakes and an interesting possible 5th type. To understand these quakes, we need to compare them to earthquakes. The main cause of quakes on Earth are the interacting tectonic plates underneath the surface. These plates sometimes shift and slide around each other, and their movement causes earthquakes. Moonquakes aren't generated from internal geologic activity, unlike on Earth. Because the moon doesn't have tectonic plates, its quakes aren't as powerful. In the past, scientists theorized that the moon was geologically dead, like it was just a big rock orbiting Earth. But we now know that the moon has quite a lot in common with Earth. The moon formed around 4.5 billion years ago from a collision between Earth and a Mars-sized protoplanet named Theia, as suggested by the giant impact theory. This event ejected material that created the moon, which shares a similar composition with Earth. Their unique tilt and angular momentum also indicate a shared origin, suggesting the Earth and Moon are alike with similar materials and structures. Thanks to the Apollo missions, we know a lot about the moon's interior structure. The moon has a much thicker crust than Earth, with an average thickness of about 40 miles. Its mantle is composed of dense rocks rich in iron and magnesium. And the moon has a small core that could be solid, like Earth's. It's likely composed of iron, and its outer core may be molten rock. Because moonquakes are different from earthquakes, they can occur in a variety of places inside the moon. Let's take a look at deep moonquakes. These happen about 500 miles below the surface. They are believed to be caused by the gravitational forces from Earth pulling on the moon. Yes, Earth is causing these moonquakes. This is because of the moon's orbit and Earth's tug on the moon's insides. The moon doesn't orbit in an even circle, so when it gets closer to Earth, the gravitational pull stretches and yanks the moon, causing the deepest of moonquakes. These usually aren't the strongest type of moonquakes, but they happen regularly and can last for over 10 minutes at a time. Shallow moonquakes. These occur much closer to the surface, around 50 miles deep. They are the most powerful type of moonquake, sometimes reaching magnitudes of 5.5 on the Richter scale. Scientists aren't entirely sure what causes them, but it might be caused by the moon shrinking, or possibly a combination of the others. Thermal moonquakes. The moon has no atmosphere, so its surface temperature changes drastically between day and night. During the lunar day, the surface heats up a lot, and during the lunar night, it gets extremely cold. This expansion and contraction of the lunar surface due to temperature changes can cause small cracks and shifts, leading to thermal moonquakes. It's also causing our moon to slowly shrink. It's estimated that the moon's total diameter has decreased by about 150 feet since its formation. Another strange reason for moonquakes are meteoroids. Hundreds of small meteoroids crash into the moon's surface each year. The impact sends vibrations through the moon, which are detected as moonquakes. This is very different than on Earth. Meteoroids usually burn up in Earth's atmosphere. These are what we know as shooting stars and meteor showers. Fun to watch on Earth, but on the moon, these are what cause the craters over time. And it could be dangerous for astronauts, but we'll leave that topic for another video. Impact moonquakes are another interesting consequence of not having an atmosphere. and our upcoming missions to the moon are sure to take them into account. Man-made moonquakes? Recently, scientists reanalyzed data from the Apollo missions and found evidence of a possible fifth type of moonquake. This one seems to be related to the Apollo 17 lunar lander itself. It's possible that the lander is settling or shifting slightly over time, causing these small tremors. As the sun rises on the moon, the lander's structure heats up and expands. This causes small vibrations in the lander, which are then transmitted to the lunar ground. And these quakes aren't rare either. It has been estimated that these small quakes happen every lunar morning, which could have a significant impact over time. In the future, when we establish larger, more permanent habitations on the moon, we need to take information like this into account as we begin to settle into our new home on the moon. So, moonquakes sound like a real problem. Although moonquakes are generally weaker than typical earthquakes, their unique characteristics and the moon's environment create specific risks for astronauts and life on the moon. Let's look at some ways that these moonquakes affect our astronauts, and what we can do about it. Moonquakes can last for several minutes due to the moon's rigid and less dampened crust. This extended shaking could cause structural damage to habitats, vehicles, and equipment, especially if they are not designed to withstand long-lasting tremors. We can hopefully mitigate some of the destruction by developing habitats and infrastructure capable of withstanding prolonged vibrations. Vibrations could disrupt life support systems such as oxygen tanks or other critical technologies, endangering astronauts that rely on them for survival. And loose regolith and rocks could shift or fall during moonquakes, posing a physical threat to astronauts that are outside their base, exploring the lunar surface. To face these challenges, NASA implements training for astronauts' emergency response during moonquakes, including evacuation or protective measures. Not only will engineering for moonquakes be a challenge, but the cost and complexity of such designs increase mission planning challenges and push back deadlines. The moon dust, or regolith alone, has cost NASA time and effort to solve around. The regolith covering the moon's surface could exacerbate the difficulty of securely anchoring structures, making them more susceptible to shaking during moonquakes. Landing and launching from the lunar surface is itself one of the biggest challenges in getting to the moon, and moonquakes could make it much more dangerous. They could create surface instabilities or trigger minor landslides, which might damage landing pads or affect spacecraft launch operations. To fix this, NASA has several ideas. Choosing mission sites away from known fault lines and areas prone to shallow moonquakes can help avoid the most dangerous moonquakes. Additionally, the Apollo missions laid the groundwork for deploying a network of seismometers. We can do the same thing during Artemis, but this time, with highly advanced technology to monitor activity and provide early warnings of incoming quakes. If future missions involve mining lunar resources, moonquakes could affect the stability of mining sites, shafts, or robotic equipment. Our large-scale human activities on the moon, such as drilling or construction, might trigger moonquakes, especially near fault lines, adding an unpredictable element to missions. Hopefully, as we gather more data and expand our knowledge of the moon, we can better prepare to avoid moonquakes and adapt to the destruction they may bring. So, now we know how moonquakes will affect our upcoming trips to the moon, how they are different from their Earth counterparts, and the interesting ways that make them so unique. In the future, our astronauts will need to make accommodations for the dangers they might cause to our settlements and life on the moon. Thanks for watching. Like or subscribe if you enjoyed the video. See you next time.